Thank you. First, let me welcome all of you who've certainly traveled more than 12,000 miles to be in Singapore. This was at 1900, right? The other interesting statistic is that in 1900, about just over 40% of the American population were engaged in agricultural jobs. Today, it'll be less than 2%. The key thing, however, is that there was a century for that transition in jobs to occur in the economy. Those of you involved in technology will know I don't think we've got another century for equally or even more gut-wrenching changes to occur. So that sets the context. Another factoid is I was just chatting with Peter Ho just now, and he said this is a strange group of people. Strange as in it's an eclectic group of people who tend to meet at various conferences, whether the conference is on cities, or on innovation, or on complexity, or on security. The same usual suspects pop up in the room. So welcome, and I look forward to your deliberations over the next couple of days. Many of us consider data to be the new currency of the future. That's one way of looking at it, in a sense, that the way we generate data, store it, analyze it, present it, exchange it, create new products and services with it, it does seem very much like currency. And the way we do all these things will affect our quality of life, will affect the viability of our economies, and indeed, even the tone and culture of our societies. So I think this is something real. Many of us also feel that we are now facing a tsunami of data. Again, Tom referred to that when he described it's 2.8 zettabytes. We lose count of the number of zeros, and the fact is it almost becomes irrelevant because the number of zeros just keep expanding exponentially. And the reason why we have this tsunami of data is because of the confluence of at least three technological trends. First, the commoditization of hardware. Computers and computing almost becomes a trivial exercise in itself. And that has led to a proliferation of both the ability to compute as well as the ability to store data. And if you think about it, if the unit cost of memory keeps falling, it should not surprise you that nowadays most people never delete photographs, they never delete emails, and the cloud providers keep giving us more and more data storage. Yes, sometimes we'll have to pay a bit, but even the free level keeps expanding. So that's one cause of the tsunami. The second is that we're now in the age of hyperconnectivity. And I don't just mean traveling more than 12,000 miles, but our human bodies, our persona, our information, our projections, our video conferences, the way the world has been so interconnected leads to the proliferation of data, the admixture of data, the commingling of data. So that's the second cause why there is this huge tsunami. We live in a hyper-connected world. The third trend is what is a slightly more recent trend, which is the proliferation of sensors. And not only that, that sensors are getting so cheap that I think we will get to the stage where sensors will be created, distributed, and they'll be too cheap to even retrieve. You just leave them in place. And as the energy requirements for sensors also falls, whether it's batteries or solar or renewable or piezoelectric, there's going to be a world in which sensors are proliferating and are ever present and always transmitting. In fact, if you think about it, the ultimate bearer of sensors are human beings. Every one of us with a phone, whether it's a smartphone or a tablet, with an enormous data exhaust that most people aren't even aware of. So if you add these three trends, computing, connectivity, and the proliferation of sensors, you understand why we're facing such a tsunami of data? Well, so now that all that data is out there, and the question then is, what and how best are we going to use it? And we now have, for those of you who are academics, I mean, coming from a medical background, we used to believe that, the classical way is you come up with a hypothesis, you create an experiment, you test it, you refine your theory. In medical science, if you wanted to prove whether something worked or not, the gold standard was a randomized control trial. So you'd have to get a control group, you'd have to randomly find another group who would be exposed to your intervention, and then you measure the results. But I think what has changed is that we now have the potential to measure everything, and to measure everything in real time. What implications does this have on academic studies, on clinical trials, on interventions, on measuring phenomena, when you no longer have to settle for a sample? You no longer have to settle for presumptions and assumptions, but indeed, you could theoretically measure the universe in real time. This is a profound new ability, which I think is going to transform academic and scientific thought. The question then is, in a new data-based economy, governments, nations, and enterprises, which are best able to mine, to analyze, and to utilize data in real time, will have a huge competitive advantage. Nowadays, when you talk about where do you think the most data scientists are employed, you tend to think of Wall Street. You tend to think of high-frequency trading firms. And indeed, the ability to move and analyze quickly in microseconds, that's a very clear example of a competitive advantage. But the real challenge is we should be using those same tools and those same skills and those same people and those same experts on a far more important business of improving our societies and governments, and not just simply engaging in speculative high-frequency trading. That is the nature of the challenge. So at the level of the city and the nation, the ability to measure everything in real time must have an enormous impact on us. And I'm just going to stop here at this moment and call my colleague Vivian, because I think he will give you a real-life example at a very superficial level at this point in time of how we in Singapore are using data and hoping to use data more intelligently. Vivian, let's get your show on the road first, and then I'll continue after that.
Thank you, Minister. Good morning, everyone. My name is Vivian. I'm from the IDA, and I head a small, kind of nascent data science team. And our mission is really to use data and work with government agencies to translate their data into ways of improving public service and public service delivery. So it's really a translational piece of work. We're not interested in kind of research or algorithms, but more in seeing how we can use the data to help public policy and help government agencies and help citizens. So one of the challenges we face in Singapore is an aging population. And it means that there are all sorts of infrastructure changes that need to take place. And what I have here is a very simple example of how we can use data to help that policy. So, with an aging population, one of the problems is accessibility and mobility. And crossing an overhead bridge is very simple. It's a sport of exercise for some of us who are healthy, but if you're elderly or you're frail, it's a pretty arduous task. So one of the challenges is how do we improve our infrastructure? And the Ministry of Transport and LTA have come up with a scheme called Walk to Ride, where they're installing lifts in pedestrian overhead bridges. Now, it's a very practical problem. The solution could be to blanket all your overhead bridges with lifts. It's an incredibly costly affair. But the question that they will have is, how do I prioritize the improvements of lifts? Because it's going to take time, it's going to take a lot of resources. So what we've done is we've done a bit of data fusion and data analysis and visualization. So we've taken the data set, anonymized data set of 500,000 elderly residents, we call them pioneers in Singapore, and a data set of kind of 2,000 pedestrian overhead bridges. It's not a big data set by any means. And what we've done is to try to combine these data sets, do a bit of analytics and do a bit of visualization, and really to help the people in transportation plan infrastructure upgrades. So I've got a kind of quick demo or prototype. It's pretty raw, but it's something that our data scientists have been working on. And what this is an interactive visualization or decision support tool that maps the density of elderly pioneers in Singapore, as well as the location of overhead bridges. So if my colleague, once you zooms into a particular region of Singapore, you're able to see that we're able to map. For example, if you hover over one pedestrian overhead bridge, this is somewhere in Teck Ghee, you see that we've got that one overhead bridge in Ang Mo Kio Avenue 1. We've also got the densities of the number of pioneers living in each of the blocks next to them. So if you hover over this particular block, 301C, you know there are about 150 pioneers. So you can do a simple algorithm basically to calculate across for each of the 2,000 overhead bridges in Singapore, the number of elderly pioneers in a 200-meter radius. Okay? And so we've got a ranking on the left-hand side of the panel, which shows you our top favorite overhead bridges that we would kind of implement, that we would improve. So once you click on one of them, you'll see that there's one in Jalan Bukit Merah, for example, which we like very much because there are a lot of elderly people around that area. You'll also see that we've taken open source data on the location of amenities and facilities. So for example, food centers and bus stops, which give an indication of the kind of activity. So we've added that into the score because the more amenities, the more food centers, the more healthcare facilities in the area, the more likely that the overhead bridges are going to be used. So this is just kind of one example of an interactive tool that we want to kind of deliver to government agencies. It's something that they can use, something that brings to bear different data sets, combining it really to help them make decisions. Now, this is just the tip of the iceberg. I think the minister talked about real-time data. This is kind of existing data, but if you overlay tons of sensor data, if you overlay the transportation network, for example, you could model, for example, the accessibility of all our healthcare facilities. You know, how accessible are they? You know, based on the transport network, not just as the crow flies. You could do integration of electricity data to look at, you know, where the elderly, you know, poverty issues and also where the elderly may be in greatest need. So I think there's tons of potential in terms of combination of data between, particularly in transport and particularly in healthcare. And this is, we think, is just the tip of the iceberg. Thank you very much.
Thank you, Feng Yan. That's just one use case. But actually, I wanted to take a step back. He's made it look easy, right? That you've got access to databases. You can put an algorithm to work. You can arrive at priorities, and you can roll out infrastructure. But there's a big but. It's not so simple. So I want to make 3 points in the remainder of the time I have with you. First, on the need for open data architecture. Second, on the need for new skills and tools which our people need to be equipped with. This relates to the university as well. And third, on changing mindsets, attitudes, and values, which such an open data-driven society and economy would require. So 3 points. So let's first deal with this issue of open data architecture and bear the example that Feng Yan has put in place. First, we've already discussed the huge volume of data which is available. But how much of that data is useful? How much of that data is readable? How much of that data is standardized? How much of that data allows intelligent decision-making to be made? So for instance, Mary Meeker, I think in her 2014 Internet Trends report, said that only about 34% of data in the digital universe is useful, but only 7% of it is tagged, and only 1% is analyzed. So we are hardly scratching the surface in terms of the potential of what we could do. The reason why we have decided to position Singapore as a smart nation rather than a smart city is because we believe we are in a unique position to overcome many of these obstacles. We are a small island state single layer of government, compact, dense, and we believe it is easier, in the case of Singapore, to put national systems and architecture in place than it would be in any other place in the world. So that's why we're trying to say we can roll things out nationwide and we can prove prototypes working in practice and refine it from there. So let me give you a few examples of this. The biggest proponent for open data and machine-readable data in Singapore is not me, it's the Prime Minister himself. For a couple of years, he's been hectoring the agencies. Don't just publish PDFs. Don't just publish printed reports. I want your data to be machine-readable. Because unless it's machine-readable and it's published timely, and preferably even in real time, you won't be able to allow that next application layer to be built on top of that in order to enable sensible decision-making. So he's been pushing us, and Feng Yan will tell you it is still a challenge. Persuading all agencies that data has to be open, data has to be machine-readable, data has to be pooled, APIs need to be published, and you need to let others bring in their own insights, insights which they will have from that commingling of data, in the same way that we have insights from an eclectic group of experts like you. This requires a change in bureaucratic attitudes and operational procedures. And another example, and this is, I'll use one closer to my own ministry, because we oversee environment and water. So for instance, NEA publishes data on air quality hourly. We publish the locations, suitably anonymized, of every single case confirmed to have dengue. We publish the locations of wherever we find mosquito larvae breeding. And this we do on a weekly basis. So there are hourly reports, there are daily reports, there are weekly and monthly reports. And even complaints are a data point. Complaints are not just a matter of embarrassment, but the frequency, the pattern, the distribution of complaints also serve as data points to give us an idea of what's brewing. And because the ultimate objective of better plans is to anticipate and to put in place systems and procedures to deal with problems even before they become full-blown problems. So that's the reason why we've positioned ourselves as a smart nation, and why we've also carefully positioned our Smart Nation project office, not as a ministry or as a separate agency, but simply as a department within the Prime Minister's office, because we want to work on a whole of government basis. We want to work with partners. We want to be a clear example of collaboration rather than reinventing wheels or doing things on our own. So that's the first thing, building open data architecture and for government to take the lead. The second point is on skill sets. We've got a pretty good education system in Singapore. And those of you who've been working with us or receive our students as undergraduates will know that. But the difference between 1900 and now is that in 1900, most people could expect to work maybe 1, 2 jobs in their lifetimes. Think what we have to prepare our students for is 2, 3, or maybe 4 jobs in their lifetime. And therefore, undergraduate education is not enough, because that's pre-employment education. But we need post-employment or intra-employment education in order to pick up the skills and the tool sets needed to deal with the changes in technology and the new equipment which is going to be made available. That's why we have now set up the new Skills Future Council, chaired by Deputy Prime Minister Tharman, to ensure that our people will be continuously upgraded, re-equipped, re-skilled for the new jobs which will be available. Because if you remember the earlier analogy, that 40% of agricultural jobs disappeared in a century. If we don't watch it, 20 to 30% of jobs are at risk within our own lifetime. So on the education, training, and especially adult retooling and reskilling front, we are committed to making a serious effort. My third point is on mindsets, attitudes, values, culture. We traditionally associate information with power, monopoly, and more power flows to monopolies. But in our organizational cultures used to be rooted in one of hyper-competitiveness, which means I want to get ahead of you and I know more than you, so I'm one step ahead of you, and you lose, I win, a zero-sum game. But there's this law called Joy's law, which holds that most of the smartest people work for someone else. Actually, what this means is that we're moving to an economy based on sharing. And you will recall I started my talk today by saying data is the new currency. But actually, the analogy fails at a certain point. Let me explain why. $1 in my pocket is mine. It's not $1 in your pocket. It's a zero-sum game. However, when you deal with ideas and data, the value is enhanced by sharing. The value is enhanced by co-creation and being able to bring different perspectives to bear. So one key mindset that has to change is this whole attitude to sharing, co-creation, co-responsibility. And having said that, we should also recognize that one key role for government in a universe where there's so much data available and so much of it is being shared, and we have created an open data architecture, is that we should also be extremely mindful of its impact on privacy, on national security, and on the fact that some of the smartest people will also be criminals and find equally innovative ways to take advantage of it. So there will be this constant push and pull between developing new tools and protecting ourselves from the basic impulses in human beings. You know, there are elements of angels and devils in human beings and in societies. And new technologies need to be addressed with this point in mind. Having said that, I think, and here I'll speak as a politician, it's well and fine to commit yourself to open data. It's well and fine to encourage everyone to share. It's well and fine to say, let's have an open source society. But there is still a need for leadership, because choices will have to be made, people will need to be convinced, and leaders will have to be held accountable. So we will have to get this renegotiation of political power, of leadership, of participation, and co-creation right. The point I'm making is that the old paradigms, where a few people had a monopoly access to all the information and made decisions which everyone just had to go along with, those days are over. But it doesn't mean that we're living in a free-for-all where data is open to everyone and everyone just makes their own choices, and out of this hubbub, order and value gets created. So my point is that, if I could just end now, is that we live in an extremely interesting age. We're facing a tsunami of data. There are enormous opportunities. Those societies, countries, enterprises that get it right have an enormous competitive advantage. We intend to play in this arena because we believe Singapore has got some unique attributes which allow us to do things more quickly, to do things more scientifically, and to plan to the maximum extent that that is possible. I look forward to your ideas and deliberations over the next 2 days, but do not forget, at the end of the day, we're not doing Smart Nation for the sake of a Smart Nation. It's got to improve the quality of life. It's got to create more opportunities. It's got to make our enterprises more competitive. And ultimately, it has to be compatible with this very human need for a sense of purpose, for values, a sense of identity. But insofar as this data revolution encourages sharing, encourages co-creation, I think these are actually positive attributes which will give, hopefully, all of us a sense of fulfillment and a sense of purpose. So thank you all for being here. I look forward to your ideas and to your criticisms as we try to improve on our vision for the future. Thank you very much.